do lesson 13 for you since I didn't have time to do this one in class. This is pretty easy. I think we learned all this in geometry, so it's just a review, but it has a little bit of algebra in it. Okay, what we have here is a circle intersected by two secants, and we want to find the angle that they intersect. So this should be simple. If they intersect inside, two secants intersect inside the circle, you add their intercepted arcs together and divide by 2. So we have 40 and 80, and we divide that by 2. We get 120 divided by 2, so we get 60 degrees. So this angle right here is equal to 60 degrees. Okay, let's move to where secants intersect outside of the circle. This one, the same thing, except instead of intersecting inside, they're intersecting outside of the circle. Anytime that's the case, we subtract the two intercepted arcs and we divide by 2. So this one, x degrees, would equal 80 minus 40 divided by 2. X degrees would equal 40 divided by 2. Whoops. And we would get 20 degrees. So this angle out here, this is littler, outside is 20 degrees. This one's the same thing. Except we have two tangent lines. Tangents intersect the circle at one point. And this is exactly the same as if two secants were intersecting outside the circle. You subtract them and divide by 2. So if we subtracted these, we would get 160. So we would get 160 divided by 2, and we would get 80 degrees. So this angle out here is 80 degrees. Now let's move from angles to segments that are intersecting inside. So we have two secant segments intersecting inside of the circle. And I think we talked about this in class. The product of this segments in this secant segment times the product of the sections of this secant segment are equal. So 30 times x plus 20, so this section times this section equals this section times this section. So it would be 40 times x plus 10. So we just solve it for x. We get 30x plus 600 equals 40x plus 400. We take our x's on one side, so we get 10x equals 200, and x equals 20. So that would be what x is equal to. Not degrees, just 20. Okay, let's look down here. This is when we have two secant segments intersecting inside of the circle. This one's a little bit different. It says if two secant segments are drawn to a circle from a point outside of the circle, the product of the lengths of the secant segment and the lengths of the external segments are equal. So what they're really saying in this is this times this equals this whole thing times this little part. Or you can say the little part times the big part equals the little part times the big part. And I have this one all set up for us. We have the little part times the whole thing, which is 6 plus 8, is equal to the little part times x plus 5. We're doing the green writing. And so if I just distribute this, if I add this together, I get 14. So I get 84 equals 5x plus 25, and I solve it, and I get x equals 59 over 5. You can leave it improper, you can make it into a decimal. I think the book leaves it improper. Let's try it with the red numbers that I have up there. And then we just have one more problem after this one. Okay, this one we have the little part, which would be 3, times the whole thing, which would be x plus 3, equals the little part, which is x, times the whole thing, which again is x plus 3. Let's see how you solve this one. It's a little bit different. So we get 3x plus 9 equals x squared plus 3x. Right away you should note that this is going to be a quadratic equation, and so in order to solve a quadratic equation you have to set it equal to 0. So I'm going to bring everything over to one side. I'm going to keep the x squared term positive. So these two guys are coming over, so we have 0 over here. We get x squared. We're subtracting 3x from both sides. So these, anytime you have the same thing on each side of the equation, they cancel each other out. Minus 9. Now it turns into a factoring problem. Most quadratic equations can be factored, or else you have to use a quadratic formula. So you get 0 equals x plus 3, x minus 3. You set each factor equal to 0, and your final answer is x equals negative 3 and x equals positive 3. And those are the two. But we'll notice we can't have a negative length, so we just cross this one out. So this would be our answer. All right, last problem up here. This one is a secant segment and a tangent segment that meet outside of the circle. This one's really different. The hard thing is remembering all of these when you go to do your problem set. The product of the length of a secant segment, so here's the secant segment, and the length of the external segment, so it's the secant segment times the external segment, equals the square of the length of the tangent segment. And you see the tangent segment is totally external. So let me show you how that plays out in this problem. So it's the little part times the big part, so it's x times x plus 12 equals the square of the tangent segment. So we just work this out. We get x squared plus 12x equals 64. And you'll note once again with the exponent of a 2 that it's quadratic. Quadratics you always set equal to 0. So you get x squared plus 12x minus 64 equals 0. And then here's another factoring problem. Trinomial factors into two binomials. We get x, and we have to think of a combination that will give us 12. So we have 8 times 8, or in this case, we get 16 times 4. I had to work a little bit for that one. So it's going to be positive, so the bigger one has to be positive. This one will be negative. Set each factor equal to 0. We get x equals negative 16, x equals 4. Once again, we can't have a negative distance, so we just cross this out, and our answer is x equals 4. So that's it for lesson 13.